Now, somewhat familiar with finding antiderivatives or integrals, we are now going to go from a general solution to a particular solution. So at the end of this lesson, you'll be able to use the antiderivative to find the particular solution of a function. All right, basically, if you're moving from a general solution to a particular solution, we basically just need to find c. Notice on all the general ones, we always put plus c, but now it's time to find c. All right, let's try an example. Find the particular solution of dy dx equals 2x minus 1, given that the point 3, 2 is on the curve. Okay, so we're going to start this one the same way that we started the other ones. Dy dx means derivative, so to get rid of the derivative, we're going to take the antiderivative of both sides. Okay, when I take the antiderivative of a derivative, I'm just left with, instead of dy, I'm just left with y. Okay, and then on the right side, I'm going to, couple different things that you could do. I think on this one I will just go ahead and distribute the 2 to both parts, so I'm going to end up getting 2x minus 2, and then I'm going to separate it into two integrals. Okay, so when I take the antiderivative or integral, and I should have bumped that 2 out front, so let's do that. So I'm going to have 2 times the antiderivative of x would be 1/2 x squared, and then minus the antiderivative of 2 would be 2x. So I'd get y equals 2 times 1/2 x squared would just be x squared minus 2x plus c. And again, you might just want to go through and take the derivative of this and just check to make sure you got what you started with, which we did. Now we have a c, and it tells me that the point 3, 2 is on the curve. So particular solution, we're just going to find c. So we're going to plug that information in for our x and our y. So we know that y is 2. We know that x is 3. And now we're just going to be solving for c. So I'm going to get 2 equals 9 minus 6 plus c. 2 equals 3 plus c, so c must equal -1. So when it asked me for my particular solution would be y equals x squared minus 2x minus 1. And that would be it. Okay, this one says to solve the differential equation. Differential, remember, has to do with derivatives. Right now it's telling me that the second derivative is equal to x squared. The first derivative at 0 is equal to 6, and the function at 0 is equal to 3. So lots of different information in this problem. If I want to solve it, my goal is going to be to end up with an equation for f of x. So it says f of x equals something, right? You'll notice they started me at the second derivative. So notice if I took the antiderivative at both sides, that's working backwards. I'm going to go from f double prime, that's going to bump me back to f prime. So if I take, let's just do both sides. If I take the antiderivative of f double prime, that's going to put me at f prime. And then I also know that the integral or antiderivative of x squared will be 1/3 x cubed plus c. Okay, now it's going to be a process of actually finding the c for this one. I do know that the derivative at 0 equals 6. This is an x value, this is a y value. So we know that 6 equals 1/3 times 0 cubed plus c. That would be 0, so we know that c is equal to 6. So if I rewrote that equation now, I'd know that f prime of x is equal to 1/3 x cubed plus 6. All right, the next thing that I would like to do is I'm still not at f, so now I'm at the derivative, so I need to go one step backwards again. So I'm going to undo the derivative on both sides here. Okay, so the antiderivative of f prime would just be f. And then this one I am going to separate into two parts and bump that 1/3 out front. So I'm going to get f of x equals 1/3 times the antiderivative of x to the third would be 1/4 x to the fourth plus 6x. And so I'd get f of x equals 1/12 x to the fourth plus 6x plus c. All right, and then let's use that information again. It tells me that f of 0 equals 3. When x equals 0, the function is equal to 3. So we're going to have 3 equals 1/12 times 0 to the fourth plus 6 times 0 plus c. And since everything will cross out, we do end up getting c equals 3. So when it asked me to solve the differential equation, my final answer would be f of x is equal to 1/12 x to the fourth plus 6x plus 3. So hopefully now you can find a particular solution of a differential equation.